All right, so if you struggled by looking at the key for the answer and you made a mistake, I can walk you through this one as well. So starting with the quotient, Z1, Z2, but using trig form, we would take the R values in front. So again, here's our R1, here's our R2, and we would divide, and we would get that root 2 over 2. And then remember, we want to subtract our angles. So if you're subtracting the angles, we now have that 7 pi over 4 minus pi. Really? Really? Minus the pi over 6. So we had already converted these, but again, just 12. This was 21, 12, and this was 2. So when we subtract them, we're going to get this root 2 over 2, kiss, 19 pi over 12. And that would be our trig form. Now, if you want to do standard form, you could take that root 2 over 2, and then what we need to do is find the cosine of 19 pi over 12, and then we are going to add to that the root 2 over 2 times the sine of the 19 pi over 12, but then just don't forget the I on that entire term. So in our calculators, we can do the square root of 2 divided by 2. I'm going to just hit enter for that, and then times that by the cosine of 19. Oh, nope. Third time's a charm. Times cosine of 19 pi divided by 12. Oh, I give up. I quit. I'm going to get this 0.183 plus, and then same thing. This time I'll use parentheses so I don't have to hit enter. So square root of 2 divided by 2. And then we can do the sine of 19 pi divided by 12. And then we will 0.68. And then we can put that I on there. So this is trig, this is standard form. Now to do this again, but using the complex form of these, hold on one second. Oh, thank you so much, honey. We can take the original two problems, and now we want to divide the 1 minus I by the root 3 plus I. Gross, remember that for this we have to use the conjugate. Blast from the past. So the reason we use the conjugate is for what happens in the denominator. Remember that when we multiply these denominators together, you're going to get the first term of root 3 times root 3, or 3. The middle terms will cancel out, but then you'll get that last term of minus I squared. Remember, I squared is -1, which is going to make this 3 minus a -1, or a 4 in the denominator. Now in our numerator, we would actually have to multiply these together to get the root 3, and then our middle terms do not eliminate. We get a minus I, a minus root 3I, and then the plus I squared. Well, if you recall, this whole term becomes a -1, so what we end up having is the root 3 minus 1. I'm going to put my real terms together. I'm going to factor out not just an I, but a minus I to get the 1 plus root 3 for my imaginary part, all over 4. So again, how did this happen? These are my real numbers. I put those together. These are my imaginary terms, but I'm going to factor out that -I, so then I can just get the 1 plus root 3. Now, this right here, we can write in decimal form. Let's start by thinking about the real part of this. If I do that root 3 minus 1, and I divide that by 4, you're going to get that 0.183 as your real part of this. And then we can do the same thing for the imaginary part. So what you'll want to do for the imaginary part is think about this 1 plus square root of 3, divide that by 4, and then don't forget to put the minus with the I. And again, you can confirm that that is in fact the same exact answer we got from up above. So please email me with any questions. Tomorrow I'll have some great practice for this for you guys.